Okay, here's problem 1. So here's the key. We're going to have the covariance of xi, xj is equal to the expected value of xi times xj minus the expected value of xi times the expected value of xj. And then similarly, kind of in the same family, the variance of xi is equal to expected value of xi squared, minus the expected value of xi, the quantity squared. Now, if you notice something interesting, if I and j are equal to each other, then the covariance is equal to the variance. All right? And we'll come back to that in a little bit. So all of our variables have mean of 0, variance of 1, and since they're uncorrelated, then the covariance is equal to 0. And that's all. We can think of that as being given. So we can write expected value of xi times xj minus expected value of xi minus expected value of xj equals 0. So that being said, I know that my expected value of xi and xj are each equal to 0. So just looking at this term, expected value of xi, xj, that's going to be 0 when I is not equal to j. When I is equal to j, you're in the variance state, and you're going to have expected value of xi squared minus 0, or 1 is equal to the expected value of xi squared. Okay. So I'm going to let w equal to x1 plus x2, and y is equal to x2 plus x3, and we're going to put these together and eventually solve for what they are. All right, hang on a second. So I have the covariance of wy is equal to the expected value of yi minus yj. And let's see. All right. So when I look at these, I just kind of lost my place. If I look at the expected value for the individuals, I'm going to have expected value of x1 plus x2, but that's just 0 plus 0 equals 0, because the expected value for any one of these is equal to 0. Therefore, we can use that. The expected value for y is also 0. Then we start putting things together. We have expected value of the quantities x1 plus x2 times x2 plus x3. And when I multiply these and put them all together, I'm going to have x1 times x2 plus x1 times x3 plus x2 squared plus x cubed plus 3, x3 x3. So we're going to have expected value of x1, x2 plus the expected value of x1, x3 plus the expected value of x2 squared plus the expected value of x2, x3. Now you notice here that each one of them, except for the third term, is a mix of some kind. So we saw that that worked out to be just plain 1 down here. And then the variance is going to be the expected value of the x1 plus x2 quantity minus the expected value of x1 plus x2 quantity. So I'm going to have the expected value of x1 squared plus 2x1 x2 plus x2 squared minus 0, 0 from the last term. And then I start putting these together. I have 1 plus 200, plus 2 times 0, which is 0, plus 1 is equal to 2. So my variances are equal to 2, and the variance of y will be identical. So I have the covariance of w comma y all over variance of the first term. So the variance of W was equal to 2, and using the same logic, the variance of Y is equal to 2, and that's going to be 1 over the square root of 2 times the square root of 2, and that's going to give me 1/4 as my answer. Okay, now for part B, it's actually 0, and the reason is the same thing that we saw in this one. We're going to have all these values, none of them have matching subscripts, so whenever we do the mix on the expected values, like we have here, the x1, x2, that's going to go to 0. So all those terms are going to 0. Expected value of x2 gives you 1, and so on. Whenever you have a square term, that goes to 1. The mixes go to 0, and you can put things together. All right, hope that helps.